Having escaped the frozen, battered purgatory of Mercury and the crushing, acid-choked greenhouse furnace of Venus, we now cross an invisible cosmic boundary. 30 million miles past our sister planet's hellscape, the chaos of the inner solar system suddenly stops, giving way to a miraculous, breathtaking sanctuary of sapphire and emerald. We call it Earth. It is a world that defies the terminal fates of its terrestrial neighbors, a magnificent, vibrant oasis drifting through an otherwise sterile and hostile desert of space. For 4.5 billion years, this world has stood as the ultimate cosmic paradox, a planet where the laws of physics and chemistry aligned in perfect, fragile harmony to spark the rarest phenomenon in the known universe: biological life. Earth resides in the Goldilocks Zone, a highly precise orbital sweet spot where the thermal radiation from our parent star is neither too intense nor too weak, allowing water to exist permanently in its liquid state. To look upon Earth from the dark void is to look upon a masterpiece of planetary resilience, a Goldilocks anomaly that serves as the only known cradle of consciousness in the deep, dark cosmos. The survival of Earth is not a matter of luck. It is achieved through continuous, silent planetary warfare. Beneath the tranquil oceans and shifting continents lies a churning subatomic powerhouse that functions as our ultimate shield. At the absolute center of the planet sits a colossal core of iron and nickel, under pressures so intense that the inner core remains a solid ball of metal, hotter than the surface of the sun. Surrounding this solid heart is an ocean of liquid metal that sloshes dynamically as the planet rotates. This mechanical motion acts as a colossal liquid dynamo, generating a massive global magnetic field that erupts from our poles and stretches tens of thousands of miles into space. This is the Magnetosphere, an invisible, unyielding fortress that wraps our planet in a cosmic armor. Without this shield, the unrelenting onslaught of the solar wind, a torrent of high-energy charged particles fired from the sun at millions of miles per hour, would strip away our atmosphere, boil our oceans into vapor, and erase our biosphere, just as it did to Mars. The vibrant auroras dancing across our northern and southern skies are the visual scars of this ongoing war, proving that our invisible fortress is actively deflecting destruction every single second. What truly separates Earth from the dead, volcanic plains of Venus and the frozen ruins of Mars is that our world is geologically alive. Earth possesses a dynamic lithosphere broken into massive tectonic plates that constantly slide, collide, and sink into the mantle below. This process, known as plate tectonics, functions as the planet's ultimate global thermostat. Through the carbonate-silicate cycle, carbon dioxide is released into the atmosphere by volcanic eruptions, weathered away by rain, washed into oceans, and dragged back deep inside the Earth through subduction zones. This exquisite geological conveyor belt prevents Earth from undergoing a runaway greenhouse collapse or a permanent ice age. Venus choked because its crust was locked. Mars froze because its internal engine died. Earth endures because its surface is in a state of eternal renewal, balancing the carbon ledger over hundreds of millions of years to maintain a climate perfectly tailored for survival. Wrapped safely inside our magnetic fortress and stabilized by its restless crust, Earth activates its most complex engine of life, the hydrological cycle. Water on this planet is not static. It is a highly dynamic planetary circulatory system. Driven by the thermal energy of the sun, billions of gallons of liquid water continuously evaporate from our vast sapphire oceans, rising into the troposphere to form a protective global shield of shifting clouds. This dense network of atmospheric moisture redistributes thermal energy across the entire globe, preventing extreme temperature spikes and carving the jagged topography of our continents through continuous weathering. Our atmosphere, composed of a highly balanced 78% nitrogen and 21% oxygen, serves as a hyper-efficient pressure blanket that keeps our water from boiling into the vacuum or freezing solid. Every river carving through stone, every storm breaking over concrete, and every wave crashing against a barren shore is a physical manifestation of this planetary engine, circulating the vital chemical ingredients required to feed a global theater of biological evolution. Yet, the magnificent stability of our sanctuary is not an eternal guarantee. It is bound to the unyielding chronological countdown of our native star. As the sun burns through its hydrogen fuel, it naturally grows brighter and hotter. In about 1 billion years, this gradual increase in solar luminosity will break Earth's fragile thermostat, triggering a runaway evaporation cycle that will boil our vast blue oceans into vapor and erase our biosphere. And on the ultimate horizon of deep time, 5 billion years from now, Earth will face its final embrace. When the sun expands into a catastrophic red giant, its roaring stellar plasma will completely swallow our orbit, melting our rocky crust, vaporizing the remains of our cities, and absorbing our entire physical legacy back into the star where our atoms first began. We are a planet living on borrowed time. Earth stands as the ultimate monument to planetary perfection, a pristine sanctuary guarded by a liquid metal dynamo and kept alive by a restless, recycling crust. It teaches us that life is not a common right of the cosmos, but a rare, fragile masterpiece that must eventually outgrow its cradle to survive. Thank you for exploring the Solar System Chronicles with Science Odyssey. If you are ready to venture deeper into the void, subscribe and join us for our next chapter, where we leave the safety of our home behind to explore the gateway to the stars, our silver companion, the moon. Thanks for watching.